Carl. Thanks so much.
Great. So this is Carl Ackerman. I'm a principal product manager here at Sophos. Sophos has been around 30 years. Most of our experience is in what we see from malware. So 30 years ago, we were an AV company. We also have products across the network side as well. So you can see here just a list of some of what we cover. I think what's important to note is with the 30 years of experience, Sophos has seen the threat landscape change. So we've seen everything from the I love you virus up to what we're seeing now for ransomware attacks. And a little bit on how that threat landscape has changed sort of gets to what we're seeing in advanced malware targeting ransom attacks. For the most part, what we're seeing today is ransomware is something that is relatively easy for a criminal syndicate to create. And that poses one of the challenges for traditional AV companies. For the most part, the way a traditional AV company detects malware today is they compare what they're seeing at the moment with what they've seen in the past. And often a malware application may have been written, it goes through polymorphism where it's changed in some way, either automatically or by the criminal directly. And we compare what we see to say, is this similar to things I've seen in the past? With ransomware attacks, with over $1 billion in damages being paid this year, a number of criminal syndicates are creating their own ransomware. So they may create a new version of a file encryption software, deliver the ransom notes, send it out through a spam phishing campaign, and collect the money. And it's very lucrative. We're seeing a number of variants of ransomware come up. And I think that's where traditional AV has a challenge in that if it's never before seen, how do I catch it? Because a lot of the techniques we have had in place for traditional AV is based on scanning the file as it comes in and taking a decision of, is this something I've seen before? And what's also lending to the threat space is a change that happened in how malware is delivered starting around 2009. Prior to that, most malware was something that would get developed, get used. As the AV companies or customers become experienced with it, you can take a look at that, create what would be called a whole file hash, and that's a unique identifier for that piece of malware. And then I can publish that as a virus update. If I ever see that unique file again, I know it's bad, I can block it. In 2009, companies that were using that type of protection from an AV stance, those AV companies died. And what happened in 2009 is a university student released a piece of software called Polypack. And the media picked this up as the first crimeware as a service. What Polypack would do, and what the industry's done since then, as a criminal, you can submit your piece of malware to this online tool. It will automatically change it, make changes to it so that it's no longer going to match a whole file signature. In addition to that, it will test it against all of the AV products that are out there. And after it's changed it sufficiently to bypass all AV, it'll give it back to you and say, here's a piece of malware that will do what you want, that none of the AV companies are going to be able to detect. And that sort of led to the explosion of what we're seeing for more advanced threats. And what we've seen in the market overall is it's created this proliferation of malware. So we're up to almost 600 million unique samples of malware. Almost a third of that is what's happened in just the last 12 months. So back here in 2007, we start seeing automatic polymorphism of malware. Today, Sophos processes 400,000 unique samples of malware per day. Most of that malware, 75% of it, is unique to the organization that it's targeting, which means that for AV companies to be at all effective, they're not based on whole file signatures and haven't been for a while. And that gets into how they go about detecting through heuristics or mathematical analysis or behavior applications. The other thing we've seen changing in the threat space, though, is the leverage of vulnerabilities to perform an exploit. So if I've created a piece of malware and wrapped it up either as a macro in a document or into an executable, I need to deliver it and it needs to execute. That delivery allows it to be scanned by an AV because it's a document or it's a .executable. if I wanted to get around the ability to scan the malware, if I can exploit your browser, I can potentially do that over the wire. And exploits have grown as a technique for delivering malware. And what we've seen happen is the software industry provides security patches. They wrap those up as very small software updates. And as an admin, you're told to go and apply them. What the criminals do is they take those same software updates, they reverse engineer them, and they discover where the vulnerability is. And then they write an exploit to take advantage of it. So we've seen that happening in ransomware attacks as well. And some of the more common drive-by exploit kits are listed here. The Angler kit itself, there's some interesting data here of, I think this was just covering parts of the US, $34 million, 90,000 different attacks per day. So these tools don't require a user to download anything. They just need to drive to, browse to a website, and it may be a website that yesterday wasn't infected. The adversaries have compromised it. They've now installed a redirector which goes to an exploit kit and will try and automatically deliver malware and execute it on the device. The other thing we've seen is that once I've exploited an application, I can run in a privileged mode. Typically, malware gets then delivered to the machine so it could get scanned at that point, but it doesn't have to be. The exploit kit can just pass off a running process thread and say you can run in memory with no payload. And we're starting to see those types of attacks. And the net result is really sort of the industry for hacking has really gone from something that an individual or a small group would do on their own to full industrialization. We see automatic polymorphism of malware. We see automatic tools for how do I convert data that I've stolen into money. We've seen organizations become very specialized. This is a toolkit that's available or was available a few years ago online. So if I wasn't skilled at software engineering and I wanted to be a hacker, I could go rent access to this tool or a tool like it, in this case Black Hole. And then I select the exploits I want to register for, maybe register for a spam campaign, and then it starts collecting statistics on the machines that it's compromised. And then allows me to go ahead and pick the piece of malware I want to deploy. And I may deploy a ransomware attack. I may have targeted some point-of-sale machines, so I'm going to deploy some credit card memory skimming to pull credit card data out. But it's become very sophisticated, and the industry's begun to fail in how it addresses. So looking more specifically at ransomware, though, all endpoint AV products should cover these three core pillars. How does it prevent a device from getting infected? How does it detect it if it is infected and running? And how does it respond when it finds it? For the most part, when you look at a ransomware attack, what it involves is the adversary needs to deliver something that's going to infect the machine or trick the user to go to a website where they can perform an exploit. Once they've compromised the machine, the adversary reaches back out to the internet to what's called a command and control server, where they exchange an encryption key material that's used to encrypt the local files. Once the local files are rapidly encrypted, a ransom letter gets delivered, and the user gets stepped through the process of how to make a payment to get their material back. For the most part, the criminals actually will deliver you your ransom key if you make the payment. So we've heard stories of a user who's become infected, didn't understand how to make a Bitcoin purchase because the adversaries were asking for Bitcoins. But the ransomware includes a link to customer support or crimeware support. They call the crimeware support, get instructions on how to make a Bitcoin payment. They actually go through that process and buy their $500 worth of Bitcoins and follow the steps to make their payment. What had happened from the time they'd purchased the Bitcoin to when they made the payment, the value of the Bitcoin had fallen. So they make their payment and it says insufficient, you're $20 short. The end user calls up the criminals and says, look, I tried, what do I need to do? And the criminals, because they want people to know that if they make a payment, they'll get their data back, because if they never gave you your data back, people wouldn't be paying. They actually said, that's okay, you've made a good faith effort, we've gotten our $480, here's your decryption keys back. Those types of stories are more and more common. And for the most part, we see ransomware attacks going after everyone. They can be fully automated. So it's everyone from going after major institutions, home users, radio shows, police departments, hospitals. If they can get that ransom attack in, they can deliver it, establish the command and control, get the files encrypted, deliver the ransom note. They're going to make money. And they make money. Last year, it was like $250 million in ransom payments. This year, it's over $1 billion in ransom payments have been made. And it's just one aspect of what's happening in the cybercrime space. So overall, in the cybercrime space, a Juniper study estimates there's $500 billion in cybercrime damages per year. And that's everything from the value of the information stolen to the cost of organizations to recover, or perhaps even go out of business if they can't recover from a cybercrime attack. And that's expected to grow to $2 trillion by 2019. In this anatomy of a ransomware attack, though, if we look at the technology that you have in place today, your traditional antivirus product probably includes some capabilities around exposure prevention, preventing users from going to known malicious websites. If they're downloading an executable, what's its reputation? If it's a USB infection, do they have controls to prevent USBs? And you'd want to make sure as an organization you're doing what your AV product allows for exposure prevention. There's also execution prevention. And as I said, most attacks are unique to the organization that they're targeting, which means whole file signatures, though a method that many AV companies use, it's probably not their primary method. They're probably doing some type of file analytic. And we see that everything from some new startups that are saying we'll use mathematical analysis of attributes to traditional vendors that are doing a very similar type approach of analyzing the file, potentially detonating it on the device or in a sandbox and observing its behavior. Given those evaluation characteristics, it gets classified as good or bad and gets ruled out. The challenge with these types of analysis, if the ransomware is a new variant, it's not going to match a pattern of previously delivered malware. The adversary may be delivering it through a spam campaign, and 2 out of 3 ransomware attacks are delivered through targeted emails. And it may be a document with a macro in it as opposed to an executable. And that will break some of the ways organizations evaluate the files. You want to make sure your AV understands the variety of mechanisms ransomware gets delivered, can scan and understand all those file types, and has a mechanism for matching. Most AV companies, and this isn't all, also perform runtime detection. So that may be detecting communication out to suspect command and control servers. For Sophos, everything shown here is available. This is synchronized security sharing contextual threat information with a firewall. Very few companies can get multiple security components to collaborate, but it's an option to get better. Looking at the runtime behavior of the application in memory. So oftentimes malware and ransom attacks are given to the machine in an encrypted state. Only when they're running do they expose their components so that they can be analyzed. So runtime memory analysis is part of it. But all of these attacks are what people have had for traditional AV for years, and we're still seeing the exponential growth of ransomware. And that's what led Sophos to say, is there another approach? Instead of saying, how similar is what I'm seeing right now to all of the ransomware variants I've seen in the past, can I do something else to detect it and stop it? And we wanted to say, at this point, the performance of a rapid file encryption is a behavior that regardless of how the application got delivered, whether it's running in memory, whether it's something we've never seen before or just a polymorph variant of something we've seen, if it gets past all of these detection techniques here, it still has to perform rapid file encryption. And what we built was the ability to monitor all processes and how they interact with the file system. If we see a process performing rapid file encryption as a basic behavior, whether it's a trusted application that may have been exploited, a Word document running a macro, if it's doing rapid file encryption, we can isolate that process. And by isolating the process, we can now examine it to see if it's a legitimate file and folder encryption software run by the user or something that we don't recognize how it's being executed. If it's not on the whitelist, we can go ahead and terminate the process. As a behavior technique, when we ran this against all the ransomware we'd seen, it caught all forms of ransomware except a type of ransomware that went after just the master boot record. So if you've got BitLocker or FileVault, and the ransomware adversary can encrypt that encryption key in the boot records, they've effectively done what they wanted. So we've added that capability, and that comes out in December for master boot record protection. The other challenge with this is it's running late. The adversary's penetrated the device and they've encrypted successfully a couple of files before I can catch them. So we wanted to address that. And what we're doing is when we see a file being interacted with by another process, we'll take a copy of it. If we convict the process of being a ransomware attack, we'll actually restore the copy. And we didn't want to use the operating system's cache mechanisms because the ransomware is aware of those and it attacks them. The other thing we've seen happening in the industry, if they're not able to do a behavior or stop it up front, a number of vendors have said, post-infection, I'll help you recover. So most organizations, as a best practice, need to be keeping backups. Those backups should be offline so that if you've become infected, you can go ahead and restore from that backup. We've seen some vendors offer an attempt at key recovery for files that have been encrypted. And what this is doing is they're working with law enforcement, and as a criminal syndicate gets taken down at some point in the future, they may be able to recover encryption keys for an attack that you suffered months ago. And it's possible you can recover that key effectively through law enforcement or what some other AV vendors have done for key recovery. This is a very rare type of recovery. You've already gotten hit, you may have refused the payment, hopefully they get taken out by law enforcement and a key gets recovered that can be pulled up from one of these tools. We also see poorly encrypted files that may be recoverable just by reverse engineering the attack, but they're fairly rare, and it tends to be far enough after the incident that it's not very helpful. So primarily your recovery from an infection that you did get hit by is backup if all of the protection techniques up front failed. Sophos' ability to add the CryptoGuard capability right now is relatively or is unique in the market. We've seen a number of companies begin to go down this path, and we expect other vendors to start adding behavior monitoring for anti-ransomware. But today, as a technique, it's very valuable. What Sophos learned from that, though, was behavior analytics is a very powerful mechanism to stop adversaries. So we also applied that in Sophos Intercept X to another problem, and that problem being, how do organizations get breached today if they already have very good antivirus and very good firewall products? And when you look at what's successful there, you find that those breaches are driven by exploits. And the exploits are driven by leveraging vulnerabilities on systems. What's interesting, though, is there's probably only 24 or so exploit methods. So Sophos acquired a company called Surfright to pick up this ability to generically detect exploits across all of the exploit methods. And what we find when we look at the market is very few companies have what we would term comprehensive exploit mitigation. Almost every company provides a level of exploit protection, so preventing buffer overflows or protecting a particular type of stack pivot. We see a number of the newer players being a little richer here. So Microsoft has an EMET tool, Malwarebytes, Palo Alto Traps. These tools tend to be fairly complex. They don't include all of the capabilities of traditional AV, but they do cover the exploit methods a little better than most of the traditional AV vendors. So the list is fairly long, and here's sort of the second half of that table on what's available with Intercept versus what's available with competitors. All of that got rolled into a product that included a root cause analysis tool. And I'll skip a lot of this section and sort of allow us to get to Q&A in a second. But in addition to stopping ransomware attacks and stopping exploits, we wanted to help people understand if malware is found, how did it get to the environment and what did it do? So the challenge to the engineering team was if when we find something bad, track backwards in time to the origin event, and then build a report that shows that threat chain and anything else that may have happened in the attack. So that's included in Sophos Intercept X as well. It gives you these kinds of diagrams so you can see from the point of infection back to a root cause. It's an automatic incident response report. It identifies suspect business files that may have been targeted. And in a ransomware attack, what you would see potentially is the ransomware was stopped. It was targeting a particular set of business files when it got captured. And you'd understand, where did it come from? Was this an email attachment that came in? Was it a browser that was compromised? Was someone running something off of a USB device? So understanding how the adversary tried to penetrate the environment is important as well. Sophos Intercept X has been out since September of this year. The key feature that we talked about today was the anti-ransomware. That same behavior technique got applied to what we did for anti-exploit. So the ability to stop the exploit behavior technique, as opposed to understanding whether this particular sample is something I've seen in the past. It includes a full incident response report so you can understand how things came in, and a cleaning capability to remove the malware in a very deep forensics way and restore the machine to execution state. That covers what I wanted to talk to today. Here's a sort of a list of features. You can see Intercept X, which includes the anti-ransomware. It is available to run alongside your existing AV. So if you have a third-party AV and you want to run this for its anti-exploit or its anti-ransomware attacks, it'll run perfectly happily alongside the existing AV product. If you do purchase it with Sophos Endpoint Advanced, it deploys as a single agent and gives you all of those capabilities we talked about, from download reputation and web protect, particularly available or useful for ransomware attacks, but also all types of malware. And integrates as a single seamless agent that can be managed from Sophos Central, a cloud-based management console. With that, I guess I'd like to open it up to a couple of questions if we have them.
We do. We do. Thank you so
Great.
much, Carl. Yeah, absolutely. So at this time, just a reminder, if you have any questions, please post them to the questions pane in your GoToWebinar control panel. And we do have a few coming in. First question, can I deploy just Intercept X without any antivirus? So
what's interesting here is you've seen a number of vendors enter the antivirus, anti-malware space, as termed as next-gen companies. Often what they've done is they've built a very specialized component, so detect malware through mathematics or Palo Alto traps, understand the variety of allowed and not allowed application behaviors. Those products don't replace traditional AV, which has everything from the web protect, the application control, the device control, the file download scanning. And very similar to those other new players, Intercept X isn't meant to replace your traditional AV. It went after a problem where we said ransomware can be stopped in a non-signatureless way, so 100% signatureless by looking at a behavior. And it can deploy alongside your existing AV. Similarly, we said, understanding when organizations get breached, how did it happen? Can we build something that is signatureless to detect that? We targeted comprehensive exploit detection. So Intercept X isn't a replacement for your AV. It's designed to augment your AV for where it's been seen to be lacking. And that can be applied alongside an existing Sophos Advanced Endpoint or alongside anyone else's AV product.
Excellent, thank you. I believe there was a use case, a specific use case with OnePoint patient care, Carl, and someone was asking if you might be able to sort of elaborate on their challenges and how cStor and Sophos were able to help overcome them.
So Dave, I think you're most familiar with what happened at that account. Do you want to talk to it?
Yeah, absolutely. Absolutely, I can take that one. This is Dave Four. I'm the local account exec in Arizona. And we worked with one of cStor's customers, OnePoint Patient Care, to help address their need for advanced point protection from both a traditional aspect and also a next-gen aspect, and they were looking at several different solutions. They were coming off of a managed services contract and bringing the solution in-house, and a couple of things they were looking for was the ability to detect and respond to, as Carl talked about, the advanced threats that they were seeing. They were having some issues with the provider that they were working with, and the tools that provider had deployed, and they knew that they wanted to bring it in-house, manage something that was easy to manage, and a couple times doing a demo and to demonstrate that we're looking for, and one of the things they were particularly concerned about, obviously, like a lot of folks, is ransomware. So we were able to provide a comprehensive solution, but one that's also simple to manage, and that's a big tenet of what we do at Sophos is making security simple from a deployment and administrative standpoint and a management standpoint. So we demonstrated that they could have the complete protection and also go deep with the protection from a next-gen perspective, but also have the simple management capability and comprehensive reporting that they were looking for that could then offset what they were getting from the current partner they had been working with, or previous partner they'd been working with.
Yeah, and just to add a little more to what Dave said on the simplicity of management, I talked to a number of organizations over the last 20 years that have gone through data breaches. Often what we find is they have relatively good security products available, but they weren't able to configure them successfully or monitor them successfully. So one of the aspects of the Sophos deployment is to make that management as intuitive as possible. And when an organization does get breached, often what you'll find, regardless of whose security products are in place, is particular security features were disabled for one reason or another. And understanding your intended security policy and auditing against what you've configured is critical. So regardless of whose security products you put in, keeping on top of your intended security posture versus the configured products is important. Sophos makes that fairly easy with the management consoles that we have. And then what we've added for behavior analytics and exploit detection, as those come in, it's a single policy to turn on, or you could have different policies by group. But by default, the product is going to deploy in a best security posture policy, and you'd have to actually go in and turn things off. So as Sophos adds additional detection models or exploit methods, those would automatically be enabled for your end users. If you wanted to disable that policy, you could go in and do it as an admin. But understanding the tools you have and are they configured correctly, that's good hygiene, and getting an assessment either from cStor's, with cStor's assistance or with your own IT admins is critical.
Carl, just a quick question. What would you anticipate as the recommended frequency for something like that audit against the security policies?
I guess whenever you're making a major change to your organizational structure, you should probably ensure that the policies you've set up work there. And then it's something that at a minimum I would do annually, and it may be something you want to do more often than that, depending on the complexity of your org.
Excellent. Thank you. We do have a few more questions, actually. What is the overhead of the exploit product?
So what Sophos wanted to do when we added the exploit detection and the RCA components and the behaviors for ransomware attacks is we realized that if we took up a significant amount of CPU or memory space, it was going to cause us significant problems for accounts. If you're deploying just Intercept X with the anti-exploit capability, the ransomware, and the data recorder, it's about 0.5% of CPU utilization, so it's basically unnoticed by the end user. And it's about 60 meg worth of memory that gets consumed for that. If you deploy that alongside the Sophos advanced endpoint, you turn all of the policies and all of the threat models on, it ends up being about 1% CPU, and I think the memory footprint of our endpoint advance is significantly higher because we're caching things. It's about 300 meg.
Excellent, thank you. I think we have time for a couple of more questions, and we'll squeeze them in. Here's an interesting one. We're in the middle of a 3-year term with our current endpoint solution. Can I still use Intercept X, or do I need to replace what I have?
So there's a couple of options. If you have a third-party non-Sophos product, absolutely you can buy Sophos Intercept X and deploy it alongside. So we've tested with all the major AV vendors. It's effectively additive to the security that you already have. You get the ransomware protection, the anti-exploit, you'll get RCA, root cause analysis, threat analysis, incident reports when we detect something. If you have Sophos today and you're already on a Sophos central deployment, you can just buy the license and turn it on. The agent will automatically update as you enable the policy features. If you're a Sophos on-prem account, you would need to migrate to Sophos Central before you could turn on the Intercept X capabilities. But anti-exploit and anti-ransomware are coming to the on-prem accounts in the January-February timeframe.
Excellent. A couple more quick questions. Does Intercept X work on servers too?
Server support right now for anti-ransomware and anti-exploit is coming in late February of Q1 next year, so early 2017. The ability to understand the threat chain and the avenue of the attack, that's not going to be available on the servers until late next year.
Okay, great. We'll squeeze one more quick question in. Thanks everyone, by the way, for all the great questions. Will Intercept X restore encrypted files if I install it after a ransom attack?
I wish I could. If you've been successfully ransomware attacked, it means that the files have been encrypted and the key for that is offline at a hacker site somewhere. We do not recover if you've deployed us after you've been ransom attacked. What we do, though, is if we are deployed and a ransom attack happens, those first few files that get encrypted, that's the behavior we're looking for. We'll recover those files to the pre-encryption state. But we have to be installed to be able to do that.
That seemed like a long shot, but thank you for answering, Carl. Great question. Yeah. Maybe someday, right? All right, that actually concludes our questions for today. Thank you everyone for your time and attention, and of course to our expert speakers,